Hi, I'm David Rierick. I'm the project manager for the Navy Mantech project Automated Metrology for Structural Assembly. This project was executed by the Penn State Electro-Optics Center at the Applied Research Labs, a Navy Mantech Center of Excellence. During this project, a collaborative team including General Dynamics Bath Iron Works, Direct Dimensions, and the Penn State Electro-Optics Center developed and refined an autonomous metrology technique for capturing large volume structures with high levels of accuracy using targetless photogrammetry. The goal was to enable lower cost in-process accuracy checks during different phases of ship construction.
I'm Thaddeus Marar. I'm a research engineer. I worked on the photogrammetry and the software automation processing.
My name is Jim West. I'm a research engineer. I worked on the imaging and system engineering part of this project. To begin the data acquisition and metrology process, the user only has to complete a few straightforward steps to use the Skydio X2D drone. 5 to 6 coded targets are placed on the structure that is to be inspected in order to scale the point cloud and align it to the CAD model. The Skydio drone is equipped to handle most of the data capture autonomously. The first step is to set up and launch the drone near the structure. Next, the floor, ceiling, and pillars are set to define the volume for a 3D scan and the boundaries for flight. With the boundary set, the Skydio flies to explore inside the volume and determines the rough geometry of the structure and the path it will follow for photo capture. Final settings are completed by the pilot and the 3D scan process is started. During the 3D scan, the Skydio flies by itself around the structure at a specified standoff distance and uses AI to collect photos at the right position and pose necessary to achieve the correct image overlap for photogrammetry. At the completion of the 3D scan, the Skydio lands and the micro SD card containing the photos is removed.
After acquisition, we start the process to transform it into a partial 3D digital twin by performing photogrammetry. We start by uploading the captured images to the server. Next, the coded targets are located in each 2D image. The surveyed coordinates of the RAD targets are used as ground control points to scale and align the point clouds to the CAD model. After this, the alignment process is started. This registers each camera into a 3D space around the structure of interest and determines how the cameras are related to each other. The alignment process results in a sparse point cloud with a rough outline of the structure and camera positions around the structure. The last photogrammetry step is to convert the sparse cloud into a dense cloud, which is the longest stage of the pipeline. The result is a dense cloud which can range from tens to hundreds of millions of points. After the dense cloud has been created, we can then calculate the deviation between the planned CAD model and the as-built structure. There's a one-time configuration when inspecting the first structure of each type to generate a recipe. We upload the original design of the structure in CAD format, as well as the dense cloud we just created. From these two items, we create a deviation map or heat map over the entire structure, showing how far each point is in the cloud from the CAD model. A second set of calculations is also performed using a previously provided list of points of interest, or check sheet. These points are locations where critical measurements around the structure are required. For the location of these points of interest, planes are calculated from the surrounding point cloud. From these planes, the associated points are extracted for comparison to the survey points or for direct use.
Accuracy was tested using a shipping container. The accuracy of our results exceeded the expectations. The histogram bias was on the order of 0.1 millimeter and indicates excellent scaling and alignment using the targets. 94% of the points are within 10 millimeters of the ground truth, and the median absolute deviation was only 1.3 millimeters. The effect of point noise is further reduced by visualization and point extraction techniques. The effects of point noise are essentially averaged out.
We need to be highly accurate, on time, every time. The idea of a drone capturing discrete points, targetless, is definitely an advantage. Not to mention the ability to collect 3D data where there is limited line of sight or inaccessible areas.
In the future, we are evaluating this technology for rapid damage assessments, 3D ship measurements while on the water, and to support repairs or planned structural upgrades.
This could be a game changer. There's no question about it, because the idea here is that this is relatively low cost equipment. It's always going to improve. I mean, we all know the improvement curve of something like drones is moving quite rapidly, as well as cameras, as well as computers as it relates to processing the data. So all of this is moving very rapidly for many other reasons besides this one project, and we get to take advantage of that. We're really excited about where this is and where it's going, where it could go, and really feel like there will be a payoff, not just for this one project, but for really what could be quite groundbreaking going forward.
The motivation of this project was to develop an automated process that could be executed by persons without extensive knowledge of metrology practices. The workflows created by this project were designed to be totally technology agnostic. This allows different capture methods, cameras, and systems to be swapped out based on the end user's needs. For instance, a drone could be replaced with an overhead cable system for low-light indoor applications requiring higher levels of accuracy. The team has also identified potential improvements to the Skydio platform that could enable inspection of increasingly complex structures. To facilitate adoption, the project team has developed a transition package that can be provided to DoD and other commercialization partners as requested for dual-use applications. While the technology used for this project has demonstrated excellent results, future hardware advancements could enable the capture of additional and more complex use cases with even higher levels of accuracy.